everyone, this is Sean Berry. I'm one of the organizers here. Today we'll be covering validation and verification as a follow-up to last week's masterclass on design definition. I know Larry here is excited to start, so with that I'll turn over to him and let him provide a quick intro to those that are new here and kick things off. Larry, all you.
Hello, everybody. Thank you so much for joining us again this week. Again, I'll just provide you with a couple different things here. A little bit about me. I'm the Senior Director of Medical Device Business Processes here at Siemens. And so we're going to have a broad discussion today. My background is really around operations, design, and manufacturability of medical devices here over the last 25 years. So hopefully this discussion will provide you with some context around design controls and how we implement design controls in medical device. Just at the beginning here, I'm going to go ahead and we'll hit this again at the end of the presentation, but this QR code will take you directly to register for our next series, which is going to be around design excellence. I'll talk a little bit about the content at that, what the content will be at the end of the presentation here. But if you want to take your camera and just show it to the QR code at the top, you'll get a link on your mobile device, and you can follow that link and it'll take you directly to the registration page. So if you want to do that here, that'd be great. Just to point you to a few other resources, I thought I'd add in some of my information. LinkedIn, my LinkedIn account is attached here, and I think we're attaching this as an artifact, a handout artifact. If you want to download this presentation as a result of this webinar, you're welcome to do that, and all the links will be attached. So we have a LinkedIn group that is Lunch with Larry, and I've also written a blog. So each one of these topics we're going to cover more extensively in written format. So if you want to pour over some of the topics and talk in more detail, the blog will include that. So I just wanted to give you some access to resources. So I'm just going to go ahead and jump in. We'll talk a little bit more about the future series at the end of the presentation, if that's okay. So just wanted to start with a discussion about one of our customers. The customer is CircuitCore. And so today we're going to talk about design control in the context of verification and validation. And CircuitCore is a great example of this. This is a friend of mine, Howard Chan down at CircuitCore. He implemented a design control, a portion of the design control system specifically around test management. And I think the key thing that we want to talk about here is really the results that they got out of implementing the system. And per their discussion, they got a 75% increase in or improvement in the time required to create test plans. And I think the reason I bring this up is, people will have different experiences as to how much improvement they get in implementing the test plan. But I also want to bring into focus the fact that people get extremely even better results when we start talking about documenting the test evidence. And so when we get our test plan, we execute on that test plan, but we end up with the test results document, and we get an even better result when we automate those test results being pulled in from the test management system. So we'll talk a little bit about how to get that done as we move through the presentation. So I just wanted to outline, it's not just the creation of the test plans, it's also the test results and the evidence collection that we get an improvement in as well. So CircuitCore is a great example of this. So I'm just going to touch on our design control process as a review. Last time we talked about the content of each of these different pillars. Last time we talked about design definition and integration of standards, how to get excellence in design reuse. Today is this green section. We're going to talk about design verification and validation. So this topic is really test case management. How do we contextualize the testing? How do we execute test runs and automate our test reporting? And next week, we're going to talk about risk management, ISO 14971 compliance, and integration of FMEA activities, calculation of residual risks and whatnot. Our next series is going to be around design excellence, which is really all about authoring designs and the activities associated with actually creating the designs. So today, again, is verification and validation. We're going to have a discussion about that. Just touch on the value in the context of testing. When we talk about reuse, last time we talked about reuse of requirements or controls. How is it that we take those requirements, we build them into documents and share them into different projects? Well, one of the really cool things about testing is testing is just another set of objects. And so we would expect to get exactly the same type of reuse out of our test cases and our test results as we do out of the requirements. So as we go through this, you'll start to see the elements that we're building, and those elements will be baked into documents, and the documents can be shared down into projects just like requirements. So productivity will be a big part of this, the value that comes out of this activity. Second thing is visualization and contextualization, and this will come in the context of traceability. So now we want to understand our traceability through the V model and how that each one of those requirement sets then links to test cases and test results. And then finally, the quality. Of course, we're going to provide some workflow and error proofing automation as a result of just this activity, just like we did the other ones as well. So of course, that all results in regulatory velocity. Okay, so let's just talk about design hierarchy here for a few minutes. What we want to do in the context of building out our design control is, and there's a whole variety, we talked about this last time, about a whole variety of different frameworks that people use to decompose their design and to provide a definition of what is good design. This is one, construction. It's a V model construction where we start with the FDA's 1998 guidance. We start with user needs and we decompose that into system design requirements, system and design requirements, and then finally design specifications. And those design specifications then become critical to quality characteristics that are consumed in our manufacturing processes. So as we start to talk about traceability to the testing, what we want to be able to do is provide a definition of what is the test, and that definition is a test case. Each one of those test cases then is linked, and we provide traceability back to the level of the requirement that it's testing. So in this case, as you can see, we have a couple different test cases, test case types. The top one is a validation test case, and the bottom ones are verification test cases. Of course, the validation test case is associated with the user need. As you can see that it traces across the top line. And then the verification test cases are related to the system requirements, design requirements, and design specifications. So these are all done, the verification testing is done on some portion of the design, maybe in a bench test or in the different, kind of environments that we do testing for the broken up design. But the validation is done on finished design using end users. And so the difference in these test cases is really what are we testing and who is doing the testing. But when we break out our design, we want to have a very clear delineation between what's being validated and what's being verified because of the nature of the test and the fact that the requirements for the test are different. And so this is really an attempt to show you when we get our traceability built out, we want to get to a place where we have a linear understanding of all the testing that needs to be done, which requirements they relate to, and we want to be sure that there's no gaps in the design as we go forward so that we don't have a requirement that hasn't been tested. And then just a note on, I'll give you another example of how we might integrate a construction of the design, a V model construction with maybe an agile construction. And so in this case, what we have is a software requirement. So essentially what we're going to do is create a design requirement that is a software requirement. In that case, what we can do then is create the software requirement. And once that software requirement is created, we can then associate it or link it to a use case in an agile development project. And so what would happen then is that use case would get executed through the agile development process, and that use case is a satisfaction to the design requirement that we've defined in the V model. So there's a lot of different ways. What I'm really trying to illustrate here is there's a lot of different ways for us to understand and do our work in different disciplines. So mechanical people have a way of working, and maybe regulatory people have a way of working, and a data construction that they've built out that makes sense to them and works for their process. But software people might have a completely different view of how we're going to do this traceability. And so what we want is a system that allows us that flexibility to say, we're going to use use cases for software, and we're going to execute those the testing against use cases. And in you know, a more traditional structure, we might have a requirement, and it's okay to have these different constructions built for different types of work that we're doing. So the next step is, once we've kind of defined what it is that, what are the controls, right? What's the performance we need to get out of the device? The next step we're going to take is to define the test. And this is really what test cases are all about. So and when we create a test case, what we're essentially doing is creating a set of steps, a description of those steps, and then what is the expected result of the step that we take in the test. So what you can see here is we execute and we write out those test steps. And when we go to execute the test, we're going to have a framework to start this, to actually do the test. And that framework is going to tell us what to do. It's going to tell us what we expect the result to be. We're going to enter in the actual result for each step and then give it a step verdict. When we're done with the execution of all the steps of the test, of course, there's all kinds of things we can do here. People sometimes block the next step because we can't do step number 2 because step number 1 failed, and therefore step number 2 was blocked. There's all kinds of different methodologies for doing this kind of testing. But essentially, we're going to roll through those steps one at a time, give a step verdict, and then when we're done with the overall test case, we're going to give the test case a verdict. It's going to be passed, failed, or blocked typically, but there's also other kinds of frameworks, as I said before. So each one of those requirements is going to have one or more test cases associated with it to assure that we provide the evidence necessary to show that we comply with that requirement. And when we finish with this activity, if we say passed, what we're going to get is a stamp on that test case for the last run of the test case that says we passed this test case, and therefore the evidence that shows that we're compliant with this particular requirement or control is now built into the database, and we have a good understanding and a traceability to that evidence. So that's defining the test. The next thing is execution of the test. So when we execute testing inside of a tool like this, essentially what we're doing is we're grouping our test cases. So we'll have a test protocol that defines all the different test cases that are associated with the topic of the test that we're going to do. So let's just say we do sterilization. We're going to do EO sterilization, or we're going to do a test of a UI for software. Whatever it is, when we test that particular UI, we're going to have a set of test cases, all the test cases that are associated with approval of that UI. And so what test execution does is allows you to group all these test cases together and then execute them in sequence. And when we do that, what you're going to get is a dashboard that gives you all the past, failed, executed test cases and what those results are. Did we have any problems associated with the execution of those tests? And of course, when we execute a test against a test case and it fails, what we do is we automatically generate a defect. And so as we go through our test sequences, we're going to get a series of defects. We handle those defects in the design one way or another. Either we're going to fix the product, or we're going to fix the specification that outlines the product, right? You're going to make some adjustments so that our specification, our definition of good, lines up with our actual performance in the field. And once that's done, we'll re-execute the testing. The defect will clear, and we end up with a 100% pass on the test run. Now, the really cool thing about this is, as we, and this is just an example of a problem reported and test evidence that's associated with the test case. So now, just to be clear, as we go through this traceability, we have our control, we have our test case, we have the test execution data, and then what we have is a pass or fail that's associated with that, and it's all built into the data model. So we don't have disassociated data. We're not executing a test in one system, having a requirement in another system, and then trying to figure out what aligns with what. It's all part of the traceability. So the next, and this is, I think, a critically important piece of doing test development, and this kind of goes back to the circuit core example that I was discussing before. What we want to be able to do is grab the data from the data model. And so one of the things, I've done this a lot in the past, and you might have 150 different test protocols in a project. You execute those test protocols, then you have to approve them before we actually do the execution, and then create the test results documents as a result of that. And I can't tell you how much time I've spent formatting these different test reports. You know, is the font right? Do we have all the headers associated with this particular type of test? Did we have the statistical analysis that we used as part of the test execution? And is that format, you know, the font sizes, are the bolds, is the content exactly the same from test report and test protocol to test protocol? And so what a big part of really getting this right is getting to a place where as we execute on all these, we have templates and we have automation that's driving the content. And so if you look at this, what you can see on the left side here are these dots. And what this is automation that goes out to a particular test run. So remember, the test run is a compilation of all the test cases that are associated with one test protocol. And so what we can do then is we can say, what are all the test case, what's the test case evidence associated with a particular test run, which is associated with the test protocol. So now what we have is a test result document that's scoped to the protocol. So there, it's a one-to-one. For every test protocol, we end up with a test report with all the test results from the test cases that are included in the protocol. I hope that's not too complicated. So essentially what we do then is we go through that test run and we say, give me all the test cases, show me all the test evidence that's associated with those tests, the last run of those test cases, and display them in this document. So this is really a key difference, you know, in this particular tool as opposed to other ones, in that we're able to create reports inside the context of a document. And so this report is just going out and grabbing all these test cases and showing the evidence. Now you'll notice we have the test result for the test case, the overall result. We have not only that, but each individual test step, what the result of the test step is. We have the test title, the execution date, who did it, any comments that are resulting from that. And not only do we have that data, we know it's right, there's no transcription errors. We know that for every execution, the format's exactly the same. All the data that we want included in that is exactly the same. And essentially this test report is, all the content of the test report is just the evidence that we've collected as a result of executing the overall system. So this test report is free, right? You don't have to add content. It all comes up as part of the execution of the report inside the document. So what I need to do then is just review the results, go ahead and put the document through its workflow, and execute an approval of that using a Part 11 compliant, electronic signature, and the test reports are done. So this is a really key aspect of documents. We want to be able to do a couple things in documents. We want to be able to include free text. A lot of times we have contextual discussion that happens around either requirements or different types of work items, and we don't want the contextual discussion is so broad that we don't want it in every one of the requirements. So it allows us to sort of write free text in a document to provide context and then provide these data elements down into the document. Second thing is really the ability to embed reports, and hopefully this really provides you with a direct illustration as to why that's so powerful. And also each different document type often has different workflow associated with it. And so we might want to have a document that is a test protocol versus a document that's a product requirements document. Those documents are going to have different approval structures. They're going to have different roles that are reviewing them. And sometimes they're going to have different artifacts that are associated with them. And so all that can be driven into the automation and the workflow management to assure that we have everything that needs to be included in the document included. And so that's the documents and the execution of the testing really go hand in hand to provide us with that rich evidence coming out of the back end so that we have all the data included in the traceability that we want. So the next step is really reporting on the status. And so this is a little bit of an eye chart, but I just want to discuss this for a few minutes. as we built out these data models, so now we have the controls built into the model, we have all the test cases, part of the traceability, but as we start to build out the data model and different people sort of put their piece into it, what we want to be able to do now is start reporting on all all the traceability. And so what this is just a screenshot of a widget-driven reporting engine that allows you to identify whatever it is that you're interested in the data model, and then provide traceability between those work items if you choose to. So this is just an example of a widget. Did this in about 3 minutes with our widget engine. Essentially, we just pull in the pie chart, and in this case, what we're doing is we're saying, show me all the different work items that are associated with this project, how many of them there are. In addition to that, I want a traceability chart that runs from user needs to system requirements to design requirements to test cases and then defects. And so because as we're building out this data model, everything is included, it's easy for us now to just start hitting the database with whatever questions that we want resolved. So if I wanted to do a gap analysis on user needs, this would give me a direct traceability to the system requirements and what the gaps are. So just to give you an example, but many, many different examples of widgets where we can just quickly pull the information we want and associate, as a matter of configuration, just associate the data model to the widgets. So reporting on the status is also a really big deal. And we kind of want to get to the place where we have this traceability all the way to the end, to the defects and or the performance. So now, as I said, we have the traceability sort of built out. What we want to do is start to think now in the next session about how is it that we're going to associate risk with each one of these controls and provide the traceability to the testing. So as we showed in the last presentation or the last slides, we have this progression in the V model from user needs to system requirements, to design requirements, design specifications, and production controls. Now what we want to do is understand how to create that progression and associate the traceability with hazard situation and harm. And once we do that, we'll have not only the traceability of the design and how to deconstruct the design, how to define what good design is, but also we'll have the context of user harms and or patient harms associated with the construction of this of the design, the contextualization of the design. And that will, of course, give us our control plan and our inspection plan. That's all part of product realization. So that's our next session. So I'm going to go ahead and drop to our next slide here, just to talk about our next, what we've accomplished so far. So this last session that we had on April 9th was related to the design definition. Today, of course, is verification and validation. Risk management is the next one. So how do we develop our process controls and integrate our FMEA activities into a 14971 compliant framework? And so that'll be the next series. So next week we'll talk about risk, but at the end of this series we're going to have a regulatory roundup with our guest speaker Jason Spiegler. He's going to come in and talk to us about the FDA and some of our regulatory discussions that we've had in the past. I also want to say that just in the spirit of post-market surveillance, we're going to have a survey, feedback survey at the end of this presentation. If you wouldn't mind taking that, we'd sure appreciate any feedback that you'd give. It'll pop up as you come out of the webinar. If you want to register for the next Lunch with Larry series, Design Excellence, this is the scan, this is the QR code again. So if you just take your phone app and use that, I'd be thrilled to have you come and join us for the bridge into the variety of different technical topics we're going to have as part of Design Excellence. We'll be adding technical experts to the discussion in the next series. So as I said before, the first one will be, of that series will be with Jason Spiegler, and the next one will be with Mark Sampson, who is our expert in model-based systems engineering. So we'll have a Q&A session with those guys. And just for reference, our Design Excellence series is really, the topic is kind of rolls through a variety of different design authoring topics. We're going to have systems engineering, We're going to talk a little bit about design authoring, so mechanical, electrical, software, labeling, a variety of different authoring techniques will be covered. We're also going to talk about improving confidence in our design, so simulation activities, got a variety of different simulation topics. And then finally, complex data management is all part of this as well, so we'll talk a little bit about how to manage the data, multi-CAD data management, simulation data management, that kind of thing. And then just finally, as we go through this series, we're going to start now. We've opened a project at Siemens that is an open source ventilator project. And what we're going to do is provide you updates as we go through the series to talk about where we're at on this ventilator project. We're going to give you some examples. We're building the ventilator into our data management system, but we're also going to talk about mechanical design and simulation, a whole bunch of different topics associated with that project. So we're excited to talk to you about that as well. So thank you for your time today. I really appreciate it. I finished a little early. I maybe should have.
Larry, actually,
slides,
we got at least one question. No, you're good. I think it's a good opportunity to tackle a question. So can you describe how this tool or approach could be used when a test case requires sampling?
Oh, when it requires sampling, well, so I'll make an assumption about what you mean by that. So very typically we have, in mechanical design, we might have how am I going to put this? We do a sample of maybe 30 parts instead of doing a one-step execution. And so oftentimes, as we do that kind of execution, in addition to that, we have a confidence and reliability. And sometimes it's a sampling plan would be more on a production sort of setup. So I'm not altogether sure what the question pertains to. So if we're going to do, if we have an AQL level that we're trying to achieve as part of a production sample, that's a little bit of a different topic than the design. So I'm going to assume that it's a 30-piece sample. So in this case, what we would do is we'd set up a test step that does the 30-piece sample. We grab all that data and provide it as a statistical analysis, and that statistical analysis would be attached to the test case. And so what we'd want to do is collect the sampling data and provide that as an analysis attachment to the data. Now, of course, when we attach something to the data, what happens is in the test results, it comes up as an artifact, which is the evidence that we're showing that we complied with what the requirement was for the test case. And that artifact shows up as the attachment in the report. So it's all part of the automation. So hopefully that provides some context. If you have more questions about that, I'm not sure I'm getting the heart of the question, but if you have more questions, give us a text on the screen, and I'll get back with you on the email. Any other questions?
Yeah, we can always do follow up. I think that was the only one that I saw, unless anyone shoots any in here. But we can just kind of wrap things up, I guess. We only got 2 minutes left now. We'll be conscious of everyone's time. But yeah, no, nonetheless, if you just open up your camera app on your phone and point it at this QR code, should take you to our our landing page for the next series. And then, of course, as a follow-up, we'll be sending out the on-demand, webinar for this one in case you want to share it with your friends, colleagues. And also, you should, hopefully it worked, the handout feature of GoToWebinar. You should be able to download the PDF for this already. If not, just shoot us either Larry or I an email. We can certainly provide that to you. I know a lot of people have already asked for that. So I think that's good. Larry, thank you very much. Much appreciated. Everyone have a good day. Good morning.
Look forward to seeing you next week.